For topic two, we're going to look at solving these equations that contain parentheses. Okay, so in the previous video, we looked at solving equations using the addition property of equality with the multiplication property of equality. So using those two properties together. This is still that same situation. We're going to have multi-step equations, so we're going to have to use both of these properties, but we're just adding like another layer to this. We're going to add parentheses now. Okay, now I do want to say something. We are dealing with linear equations. This isn't something I'm going to get too hung up on. This would be much more important if you were going more into an algebra pathway. But I do want you to know, like, if I say something about a linear equation, it just means we have exponents. Let me scoot this out of my way. We have exponents of 1 on the variable. And we're at a point where we're looking at linear equations in just one variable. That means you can have variables in multiple terms, but it's going to be the same variable, and they all have to have an exponent of 1. Now, exponent of 1, you're like, I don't see any exponents of 1. No, you don't. Because if we have x to the first power, we would write it as just plain x, okay? So if I do start saying like linear equations, just know that's what we are technically talking about. We are technically solving linear equations, and it just means this stuff right here, okay? Now, we do need to remind ourselves of something called the distributive property that we talked about earlier in this chapter, okay? The distributive property allows us to eliminate parentheses by multiplying through a sum or difference, okay? We practiced this earlier in this chapter, okay? Now we're getting ready to apply it, all right? So the distributive property basically says if you have A times in parentheses B plus C, you can multiply through those parentheses by just multiplying that A by everything inside the parentheses. So we could take this A, multiply it by B, take the same A, multiply it by C. So A times B plus C in parentheses is the same thing as just A times B plus A times C. And then over here, I'm just saying, hey, the same thing works with subtraction. If you have A times B minus C in parentheses, that is A times B minus A times C, okay? So now, when it comes to solving equations that have parentheses, you're kind of going to be dealing with all of the steps that are possible at this point in your math career, okay? So this is kind of like a general strategy for solving right here, okay? Now, students are forever saying, do I have to show that step? Do we have to show that step? And I frequently say, why, yes, you do, okay? But here is the thing. A lot of times, the method that your instructor gives you is the most efficient method. This right here, this stuff right here, this is really pretty much the most efficient way to solve your equation. So if you can follow this, it is going to be a time saver in the end, okay? So what we want to do is always use the distributive property to get rid of parentheses first. After you get rid of parentheses, you want to simplify each side of the equation. And remember, we want at most two terms on each side, one variable term and one constant term. All right, so simplify the left down to at most two terms, simplify the right down to at most two terms. And then we start applying our properties. So after you get two terms on each side at most, you want to apply the addition property of equality. What that allows us to do is get the variables on one side of the equation and the constants on the other side of the equation. And then finally, at the very last step, you would apply the multiplication property of equality. So let's look at two pretty straightforward examples. Our goal in this class is not to go super, super deep in the algebra. Our goal is to give you enough algebra so that you can go into the classes that are coming your way, okay? So we want to just build just like a pretty basic foundation here, okay? So for example 2, it says solve each equation and check the solution. We'll definitely check the solution for part A. Depending on the length of the video, we may or may not check the solution for part B, okay? Now part A, we have 5 times in parentheses x minus 4 equals 20. Well, we have parentheses, and the first thing we want to do is get rid of parentheses, okay? Don't worry about any kind of simplifying. Get rid of your parentheses first, okay? So I need to take this 5 right here and multiply it by the x and then again by the negative 4. So 5 times x, I literally just write them side by side. 5 times x is 5 with an x beside it. And then I want to take 5 times negative 4. Since we have a minus 4 here, treat it like a negative. 5 times negative 4 is going to be negative 20. When you take a positive and you multiply it by a negative, you get a negative product. All right. So what we have right here is 5x minus 20 equals 20. Okay. Now on the left, I have two terms, a variable term and a constant term. On the right, I have just a single term. It's a constant term. So at this point, we can start applying the addition property of equality. We want to get all of our variable terms on one side of the equation, which we naturally have. All of our variables are already on the left. So what we then want to do is move all of our constants to the right. We want to get just the variable term all by itself on the left. So what I need to do now is move this minus 20 that's on the left. Well, how would I undo minus 20? Because remember, at the heart and soul of all of this, we're just undoing what has happened to the variable. Well, to undo this minus 20 in math, I would use addition. So I'm going to add 20 to both sides of the equation. On the left, 20 minus 20 or negative 20 plus 20, that is 0. 5x minus 0 or 5x plus 0 is just 5x. And then on the right, 20 plus 20 is 40. Okay, so we have 5x equals 40. At this point, we've got a single variable term equaling a single constant term. This is when you apply the multiplication property of equality. So I need to undo, again, remember, heart and soul of this is undo what's happened to the variable. I need to undo multiplication of 5 and x. And in math, we undo multiplication with division. So I'm going to divide both sides of this equation by 5. On the left, 5 divided by 5 is just 1. So I'm left with just 1 times x, which is x. And then 40 divided by 5 is 8. Okay, so let's go ahead and check our solution. So when you check your solution, you want to plug it back into your original equation. So I get 5 times parentheses x minus 4. And remember, we're saying x is 8. So 8 minus 4 equals 20. So we want to use the order of operations. The order of operations says take care of what's in your parentheses first. So I would get 5 times, well, 8 minus 4 is 4. And then on the left, 5 times 4 is 20. And we can see that 20 really does equal 20. So we can say with confidence that our solution is x equals 8. And remember, we can also write it kind of fancy where we use what's called solution set notation. So we use curly braces and then just take the value for x, not the x equals, just the value itself, and put it inside the curly braces. These two things say the same thing. They say the solution for our equation is x equals 8, okay? Or it is the set that contains the value 8. All right, for part B, we have two sets of parentheses. So we have one set on the left, one set on the right. So let's go ahead and start distributing. On the left, I have 6 times in parentheses 5 plus x. So I want to take 6 times 5. Well, 6 times 5 is 30. And then I want to take 6 times x. 6 times x is just 6x. We just write them side by side. And then on the right, I have 5 times in parentheses x minus 4, which should be fairly familiar to you because it actually was in the previous problem too. By accident, I just picked two that had the same setup. But anyway, 5 times x is 5x. And then 5 times negative 4 is minus 20. Okay, so we're at a situation where we can apply the addition property of equality. We have at most 2 terms. So on the left, we have exactly 2 terms, one variable term, one constant term. On the right, we have exactly 2 terms, one variable term, one constant term. Let's start getting the variables first. I always start with my variables. Let's move all the variables to the left. So that means this positive 5x needs to move. So positive 5x, think of that as plus x. So the way we undo addition is subtraction. So I'm going to subtract x, or I'm going to subtract 5x from both sides. On the left, I've got my 30. It stays for now. And then I've got 6x minus 5x, which is just x. And then on the right, I have 5x minus 5x. Well, that's just 0. And then 0 minus 20 is negative 20. Okay, well, I still need to get my x alone. Okay, so on the left-hand side, we have our x term, but the issue is this plus 30. We need to get all of the constants on the side opposite the variable. So let's move this 30. Since it's positive, we think of it as plus 30. We undo addition with subtraction. So 30 minus 30 is 0, leaving you with just 0 plus x, or just x. And then on the right, we get minus 50. And we're actually done at this point. We don't even have to use the multiplication property of equality because the coefficient on x is already just a positive 1. Okay, now we do have, I think, enough time here. This didn't go too long. So let's check our solution. So we're going to take 6 times 5 plus x, where we're saying x is minus 50. and that's going to equal 5 times x, which is minus 50 minus 4. So let's see here. We're going to get 6 times, in parentheses on the left, we have 5 plus negative 50. That's the same thing as just 5 minus 50. However it works for you, if you like the subtraction or if you prefer the addition, knock yourself out. Either way, we end up subtracting here, even if you keep it in addition, because we're trying to find the difference in the positive and the negative. We're adding two numbers with different signs, essentially. So we subtract 50 minus 5 is 45, but is it positive or is it negative? Well, we have more negative here than we do positive, so this is going to be minus 45. On the right, we get 5 times. Well, here we have negative 50 minus 4, so that's going to be negative 50 minus 4 more, so it's going to be minus 54. If you would prefer, you could write minus 50 minus 4, or negative 50 minus 4 as negative 50 plus negative 4, and then you're adding two values that have the same sign. So we add and we keep whatever the sign is. Either way, you're going to get negative 54. Now, I'm not going to do the side work for 6 times negative 45. I get negative 270. I'm also not going to do the side work for negative 54 times 5. But I get on my calculator negative 270, so everything checks out. We can say with confidence that x is equal to negative 50, or we can make it fancy and you can do solution set notation. So remember, solution set notation is curly braces, and then you just put the number for x inside. So both of these say the value that satisfies the equation is going to be negative 50. Okay, so that's it. That's solving these multi-step equations. I don't want to overwhelm you by doing too many examples, but this is the process here. Okay, so when you're dealing with parentheses, get rid of your parentheses first. Simplify each side of the equation. You want at most 2 terms on either side of the equation. And then you want to apply the addition property of equality to get all of your variables on one side, your constants on the other, and then finally apply the multiplication property of equality to get the x by itself. Okay, and that's it for this. Oh, I've got one more. I was about to say that's it for this video. That's it for this example. We've got one more whole example right here. So I was getting way ahead of myself. All right, let's look at these last two. So example 3, same thing, solve the equation, check the solution. So let's get to it. I don't know why I did 2 examples here. Maybe I wanted to do 4 parts to the first example and it just wouldn't fit on that page. I don't know. But anyway, let's keep going. Okay, so for part A, we have 2 times, in parentheses, 3x minus 2, minus 2 times parentheses, 5x minus 2x, or 5 minus 2x, and then that all equals 4. Okay, so we need to distribute twice. So let's go ahead and get to it. So I'm going to start with 2 times 3x. Well, 2 times 3x, I multiply the 2 and the 3. So I get 6, and then I just keep the x. And then 2 times negative 2, that's just going to be negative 4. Now we're done with the first set of parentheses. The second set of parentheses, we have a negative 2 because we have minus 2. We're going to treat it like a negative. We have a negative 2 that we need to distribute. So negative 2 times 5, well, multiplying a negative and a positive gives you a negative product. So we're going to get negative 10. And then negative 2 times negative 2x, when you multiply two negatives, that becomes positive. So negative 2 times negative 2 is going to be plus 4. And then we just keep the x, and that is all equal to 4. Okay, we for sure need to simplify the left-hand side. Remember, we want to simplify each side of the equation separately to where we have at most 2 terms. So on the left, let's start with the variables. We have 6x plus 4x. Well, 6 plus 4 is 10, so that just gives us 10x. We also have minus 4 minus 10, so that's like negative 4 minus 10. So you can think of it as negative 4 minus 10 is negative 14. That's fine. You could think of this as negative 4 plus negative 10. Either way, you're adding two numbers with the same sign. You add and you keep the sign. So you're going to get minus 14 or negative 14 either way. Okay? So now we've got all of our variables already on the left. You can see there's one variable term and it happens to be on the left. So we're going to keep it where it's at. We're going to move the constants to the right. So what would I do to move minus 14? Well, remember, this is a game of just undoing. Okay, so what has happened to the variable? It's been multiplied by 10, then we subtracted 14. How do we undo subtraction of 14? We add. So we're going to add 14 to both sides. Well, I got ahead of myself here, and that should be a 14. Okay, so on the left, negative 14 plus 14, that's just 0, okay? And then 10x plus 0 is just 10x. And then on the right, we have 4 plus 14, that's just 18, okay? So then at this point, we have a single variable term equaling a single constant term, so we want to undo the multiplication of 10 and x. So to undo multiplication, we divide. So 10 divided by 10, well, that's just really 1. So I get 1 times x. And then 18 divided by 10, we want to just write it as a fraction. These are both divisible by 2 because they're both even. So I would write this as 9/5. Okay. Now, when it comes to 9/5, we generally, when we have just like a generic equation, like there's no word problem involved, it's just an equation like this. If you're starting with integers, your final answer needs to be an integer or generally a reduced fraction. If you're starting with decimals and you get something that's going to be like fractiony or decimally, sometimes it's okay to write your answer as a decimal, like if it's a terminating decimal. But if it's a repeating decimal, you always want to go with the fraction. So something like this, it's much more common to see the fraction than it is to see the decimal, okay? However, with that said, 9/5 is the same as 1.8, okay? 1.8 is going to be a heck of a lot easier to check. So let's go ahead and check. We're going to try 2 times 3 times 1.8 minus 2 minus 2 times 5 minus 2 times 1.8. We're going to see if this really does equal 4. Okay, so we're going to check our solution. Now, I'm going to do this just in my calculator pretty quick. So let's see, 3 times 1.8 minus 2, that's 3.4. 5 minus 2 times 1.8 is 1.4. And we want to see, does this really equal 4? So let's see, 2 times 3.4 is going to be what, 6.8? And then 2 times 1.4 is what, 2.8? And then we can see that 6.8 minus 2.8 really is equal to 4. My dog's about to start barking, just FYI. So we verified that 1.8 or 9/5 really is the solution to this equation. So I kind of checked it sort of quick down here, but you can hopefully follow those steps. So we have our final solution, x equals 9/5, or we can write it fancy and say x still equals 9/5. We can just write a solution set notation. So the solution set notation basically says the solution contains the value 9/5. Okay, let's do one more and then we really are done with this video. Okay, so we have 4 times 3x plus 4 minus 20 equals 3 plus 5x. We definitely want to start by distributing. So on the left, we have 4 that we need to distribute through 3x plus 4. So I want to take 4 times 3x. Well, 4 times 3 is 12, and then we just keep the x. I then need to take 4 and multiply it by this 4 over here. So 4 times 4 is 16, and then just rewrite the rest of the equation. So we want to drop down minus 20 equals 3 plus 5x. Okay, well, the left-hand side can be simplified. I have a single variable term, but notice here I have 2 constant terms. So let's simplify our constants. 16 minus 20, that's going to be negative 4. If you need to think of 16 minus 20 as 16 plus negative 20, that's okay. Hopefully you can get to the point where you practice this enough where you don't always have to do the side work for something like this. 16 minus 20 is pretty straightforward. But here we're adding 2 numbers with different signs. So we want to find the difference in the positive and the negative. So once I rewrite it as addition, I really subtract because my signs are different. And I get 4, and then I have to decide, is it positive or is it negative? Well, I have 16 positives, but I have 20 negatives. So I have more negatives than positive, which makes this negative. Okay? So either way we slice it, we're going to get 12x minus 4 equals 3 plus 5x. So we're at a good spot here. We have simplified. We have at most 2 terms. In fact, we have exactly 2 terms on the left. We have exactly 2 terms on the right. Each side has 1 variable term and 1 constant term. Now we can start taking steps to get our variables on one side, our constants on the other. So let's move our variables to the left, okay? So on the right, I have this plus 5x. I want to move it to the left, okay? So since it's a plus 5x on the right, to undo that, I would subtract. Well, on the left now we have 12x minus 5x. So just subtract your coefficients. 12 minus 5 is 7. And then we keep the x. And then just drop down everything that's left. So we have minus 4 equals 3. And keep in mind on the right, 5x minus 5x, we get lazy. We say they cancel. Just know it really just becomes 0. 0 plus 3 is just 3. Okay. Now I want to get my 7x alone. The issue is this minus 4. I need to move it. Since it is minus 4, we undo subtraction with addition. So I'm going to add 4 to both sides. Well, negative 4 plus 4 is 0, right? So we get 7x minus 0, which is just 7x. And then we get 3 plus 4 is 7. Okay, so we have it down to a single term on each side. The left, we have our variable term. The right, we have our constant term. We can now officially get the x alone. Let's undo what has happened to x. Finally, x is being multiplied by 7. We undo multiplication with division. So on the left, 7 divided by 7 is just 1. And then 1 times x is just x. And then on the right, 7 divided by 7 is still 1. We can hopefully pretty quickly check this one. So we have 4 times 3x, but x is really 1, plus 4 minus 20 equals 3 plus 5 times x, which is 1. Okay, so it's a little scrunch, but hopefully you can see it. So let's see, on the left inside parentheses, we have 3 times 1, which is 3. And then 3 plus 4 is 7. So we get 4 times 7 minus 20 equals, well, on the right, we have 3 plus 5 times 1. 5 times 1 is just going to be 5. Let's go back to the left. So on the left, we have 4 times 27, which is really 28. So we get 28 minus 20 equals 3 plus 5, which is 8. And then on the left, 28 minus 20 is 8. So we can say with confidence, our solution really is x equals 1. Or again, we can make it fancy and we can write it as solution set notation, okay? So officially, we are done with this video. Sorry, I genuinely didn't remember that I had 2 examples here. So just as a very, very quick recap, again, when you have parentheses in your equation, the first thing you want to do is get rid of your parentheses. After you get rid of parentheses, simplify each side. You want at most 2 terms on the left, at most 2 terms on the right, one being a variable, one being a constant on each side. Then you can apply the addition property of equality. That gets your variables on one side of the equation and then your constants on the other. This can definitely be a 2-part step. And then finally, at the very, very end, you divide by the coefficient of x. That's technically applying the multiplication property of equality. And that gets your variable finally by itself. And that is truly the end of this video. So the next video, we're going to talk about direct translation.